this. Journey with me as we face, overcome, and befriend the challenges ahead. We can because we are Mathematics Inyan. I am Teacher Andrew, your soulmate. Allow me to guide you in learning the different concepts and skills in Mathematics 9. In the previous episode, one of the skills I taught you was to solve quadratic equations, and one of the methods in doing so is using the quadratic formula. And since we should not bury the skills and concepts we have previously learned, we say, past not dead. Let us solve for the roots of the following pairs of equations using the quadratic formula. Notice that all equations are in standard form already. Let us identify the value of the coefficients a, b, and c in the equation 4x squared plus 4x plus 1 equals 0 of the first pair. The leading coefficient is 4, so a is equal to 4. The middle term's coefficient is 4, so b is equal to 4. While the constant term is 1, so c is also equal to 1. Let's substitute these values in the quadratic formula to determine the roots of the equation. X equals negative 4 plus minus the square root of the quantity 4 squared minus the product of 4 and 1 all over 2 times 4. Then we simplify. We simplify the expression under the radical sign as 16 minus 16 because 4 squared equals 16. And this is decreased by the product of 4, 4, and 1, which happens to be 16 also. The denominator becomes 8 because 2 times 4 is equal to 8. In the next line of solution, we show that 16 minus 16 is equal to 0. Thus, 0 is what appears now under the radical sign. Since the square root of 0 is 0, the numerator is now simplified as negative 4 plus minus 0. At this point, we break down this equation into 2 to separate the plus sign from the minus sign. Hence, the equations x sub 1 equals negative 4 plus 0 all over 8, and x sub 2 equals negative 4 minus 0 all over 8. Then we solve for x. We express the answer as a fraction in simplest form if the root is rational but not an integer. X sub 1 is equal to negative 4 over 8, which is equal to negative 1/2 when reduced to its lowest term. X sub 2 is also equal to negative 4 over 8 and hence equals negative 1/2 when expressed in its simplest form. So, the two roots of the equation are equal. We go through the same process for the second equation in the pair, which is x squared plus 6x plus 9 equals 0. Here, a is 1, b is 6, and c is 9. Substitute the values of the coefficients. X equals negative 6 plus minus the square root of the quantity 6 squared minus the product of 4, 1, and 9 all over 2 times 1. Simplify. Under the radical sign, what appears now is 36 minus 36 because 6 squared equals 36. 36 is decreased by the product of 4, 1, and 9, which is equal to 36. The denominator becomes 2 now, since 2 times 1 is just 2. And since 36 minus 36 is equal to 0, 0 now appears under the radical sign. In the next line of solution, we see that the numerator is now expressed as negative 6 plus minus 0 because the square root of 0 is just 0. Break down the equation into 2. Thus, the equations x sub 1 equals negative 6 plus 0 all over 2 and x sub 2 equals negative 6 minus 0 all over 2. Then solve for x. Both values of x can be simplified as negative 6 over 2 or negative 6 divided by 2. Increasing or decreasing a number by 0 yields the same number. Dividing negative 6 by 2, we get that x sub 1 and x sub 2 are both equal to negative 3. The two roots are integers and they are also equal. So, what have you observed about the first pair of equations? Did you notice anything they have in common? Look at this. Any idea? How about if I highlight something here? Would you be able to identify the first thing the two equations have in common? We see that in solving for the roots of the equations using the quadratic formula, the values of the expression b squared minus 4ac, which is under the radical sign and is called the discriminant, are both equal to 0. Aside from this, were you able to spot another similarity? Let's see this detail. What do we say about the roots of each of the two equations? The roots are equal. Aside from being equal, we can also observe that the roots are what kind of numbers? Rational. A number is rational if it can be expressed as a quotient of two integers. A rational number is either a non-integer or an integer. So, for the first pair of quadratic equations, we take note of the following details. The discriminant is 0. The roots are equal and rational. Let us get to know another type of discriminant that corresponds to another nature of roots of quadratic equations as we work on the second pair. 3x squared minus 8x plus 5 equals 0 and x squared minus x minus 42 equals 0. We solve the equation 3x squared minus 8x plus 5 equals 0 first. The values of the coefficients are as follows. A is 3, b is negative 8, c is 5. X equals negative of negative 8 plus minus the square root of the quantity negative 8 squared decreased by the product of 4, 3, and 5 all over 2 times 3. Then, we simplify. Here's what we should get. X equals positive 8 plus minus the square root of the expression 64 minus 60 all over 6. 64 minus 60 is equal to 4. Thus, 4 is what appears now under the radical sign. The principal root of 4 is 2, so the numerator is now expressed as 8 plus minus 2. Next, we break down the equation into 2. X sub 1 equals 8 plus 2 all over 6, and x sub 2 equals 8 minus 2 all over 6. Then, we solve for x. X sub 1 is equal to 10 over 6 and can be simplified as 5 over 3. X sub 2 is equal to 6 over 6 and can be simplified as 1. The roots are not equal, but they are both rational. Let's now solve the second equation in the second pair, which is x squared minus x minus 42 equals 0, where a is 1, b is negative 1, and c is negative 42. X equals the negative of negative 1 plus minus the square root of the quantity, the square of negative 1, decreased by the product of 4, 1, and negative 42 all over 2 times 1. After substituting the values of the coefficients in the formula, we simplify. Here, we see that negative of negative 1 is equal to positive 1. Under the radical sign, we see that the discriminant is now simplified into 1 minus negative 168. This is because negative 1 squared is equal to 1, and the product of 4, 1, and negative 42 is negative 168, and 2 times 1 is equal to 2. 1 minus negative 168 can be rewritten as 1 plus 168, following the rule in subtracting integers, which states that we change the sign of the subtrahend, then proceed to addition. Hence, the value of the discriminant is 169. The principal root of 169 is 13. Hence, the value of x is simplified further as 1 plus minus 13 all over 2. Then, we break down. But we will not cry! X sub 1 equals 1 plus 13 all over 2. X sub 2 equals 1 minus 13 all over 2. Then, we find the value of x, not of your x. X sub 1 equals 14 divided by 2, and hence, one of the roots of the equation is 7. X sub 2 equals negative 12 divided by 2, and therefore, the other root is negative 6. And we're done. But I don't mean to say I'm done with you. We have just solved for the value of x. We see that the roots of the equation are not equal either, but they are also rational. Now, let's look into the discriminant of each equation in this pair. 4 and 169 are the discriminants. They are both positive or greater than 0. Also, they are both perfect squares. If this is the case, it appears that the roots of the equation are not equal, but are rational. Let's add this observation to our table of highlights. We proceed to the third pair. 5x squared plus 10x plus 3 equals 0, and x squared minus x minus 3 equals 0. This pair shall introduce us to a different case of discriminant-root relationship. Let's solve the equation 5x squared plus 10x plus 3 equals 0 first. Just like the old times, since we are to use the quadratic formula, we first identify the value of the coefficients in the equation. Then, we replace a, b, and c in the formula with their corresponding values. Hashtag not irreplaceable. X equals negative 10 plus minus the square root of the quantity 10 squared decreased by the product of 4, 5, and 3 all over 2 times 5. Then, we simplify. Hashtag it should not be complicated. What appears now under the radical sign is 100 minus 60, since 10 squared is 100, and this is decreased by the product of 4, 5, and 3, which is 60, while the denominator is simplified as 10 because 2 times 5 is 10. 100 minus 60 is 40. Hence, the discriminant of the equation, which appears under the radical sign, is 40. And 40 is not a perfect square number, but it has perfect square factors, the greatest of which is 4. So, we express 40 as the product of 4 and 10, and then take out the square root of 4, which is 2, and retain 10 under the radical sign. Hashtag remember how to simplify radicals. Now, we can split the equation into 2. X sub 1 equals negative 10 plus 2 square root of 10 all over 10. X sub 2 equals negative 10 minus 2 square root of 10 all over 10. And then, solve for x. We cannot combine a rational number and an irrational number, but we can simplify the answer by making use of GCF, or greatest common factor. Negative 10, 2, and 10 are all divisible by 2. Hence, x sub 1 equals negative 5 plus square root of 10 all over 5, and x sub 2 equals negative 5 minus square root of 10 all over 5. The roots are not equal. And what kind of numbers are these roots? Irrational. Are you irrational? Alright, we now move on. Yes, we need to move on to the second equation in the third pair. We go through the same procedure. Remember C as 4. C is for coefficients. First S is for substitute. Second S means simplified. Square root of 13 is not perfect square, and its only perfect square factor is just 1. Hence, square root of 13 will just be expressed as is. Third S stands for split. We split the equation into 2. Fourth S is solved for x. And the GCF of the coefficient and constants here is just 1. We can already label 1 plus square root of 13 all over 2 and 1 minus square root of 13 all over 2 as the roots of the equation. Next, let us classify the discriminant of each equation in this pair and its influence on the nature of roots. Again, the discriminant is the value of the expression b squared minus 4ac that appears under the radical sign. 40 and 13 are both positive, but they are not perfect squares. Observe that the roots that correspond to such type of discriminant are not equal and are irrational. We record this in our table of highlights. And we're down to the last pair of quadratic equations, which will acquaint us with another type of discriminant root relationship. Let's solve the equation x squared plus 4x plus 6 equals 0 first. We apply CS4. C is for coefficients. First S for substitute. Second S for simplify. There exists no number that when multiplied by itself yields a negative result. So, the square root of negative 8 stays as it is. It is, in fact, an example of an imaginary number. It is not a real number. Third S is split. Fourth S is solved for x. In this case, since we can combine real and imaginary numbers, we don't need to do anything to solve for x. So we take negative 4 plus the square root of negative 8 all over 2 and negative 4 minus the square root of negative 8 all over 2 as the roots of the equation of the form that doesn't use the imaginary unit I. Next, we solve the other equation in the last pair. X squared minus x plus 5 equals 0. Never forget CS4 when using the quadratic formula. C for coefficients. First S is substitute. Second S is simplify. There exists no number that when multiplied by itself yields a negative result. So, square root of negative 19 stays as it is. It is in fact another example of an imaginary number. It is not a real number. Third S is split. Fourth S is solved for x. 1 plus the square root of negative 19 all over 2 and 1 minus square root of negative 19 all over 2 as the roots of the equation of the form that doesn't use the imaginary unit I. Now, let's look back on the type of discriminant that we can associate with the kind of quadratic equations in the fourth pair, and what nature of roots corresponds to such discriminant. Negative 8 and negative 19 are both negative or less than 0. Notice that when the discriminant is negative or less than 0, it will result to roots that are not equal and are imaginary. Let's add this observation to our table of highlights. And by the way, rational and irrational are the two types of real numbers, the opposite of imaginary numbers. Let's add this detail to our table of highlights. So, if the discriminant of the quadratic equation is 0, the roots are equal, real, and rational. If the discriminant is positive and perfect square, the roots are unequal, real, and rational. If the discriminant is positive and not perfect square, the roots are unequal, real, and irrational. Now, if the discriminant is negative, the roots are unequal and imaginary. And before we might even suffer from short-term memory loss, let's keep the learnings fresh by answering activities. Math the moment! For the first part, given the value of the discriminant, we will describe the nature of the roots. We recall our table of highlights. Discriminant number 1, negative 17. What is the nature of the roots? For 5 seconds, let's do this. And freeze. What's the answer? Negative 17 is negative or less than 0. Thus, the roots are unequal and imaginary. Discriminant number 2. 200. What is the nature of the roots? Your answer in 5, 4, 3, 2, 1. Time is up. 200 is positive, but not perfect square. So, the roots are unequal, real, and irrational. Discriminant number 3. 2025. What is the nature of the roots? Timer starts now. Stop, look, and listen. 2025 is perfect square. Its principal root is 45. Thus, the roots are unequal, real, and rational. Next part is, given the quadratic equation, we determine the value of the discriminant and describe the nature of roots. Remember that the discriminant is the value of the expression b squared minus 4ac. Are you ready? Kagamath, ready your paper and pen. Let's do this. Equation number 1. X squared minus 2x plus 4 equals 0. You have 15 seconds. Go! Time is up. Pen down. The value of the discriminant is negative 12. It is negative or less than 0. See the computation. Hence, the roots are unequal and imaginary. Equation number 2. X squared minus 9x plus 7 equals 0. Your answer in 15 seconds. Let's do this. Time up. The discriminant is equal to 53. See the computation. It is positive, but it is not perfect square. So, the roots are unequal, real, and irrational. Equation number 3. X squared minus 14x plus 49 equals 0. Your answer in 15 seconds. Let's do this. And time is up. Discriminant is equal to 0. See the computation. It is exactly 0. So, the roots are equal, real, and rational. We shall answer another activity, but this time it is a bit, or should I say, extra challenging. It's super math. So, here's what we have to do. Find the values of k for which the roots of the equation are equal. Alright, so we can see that the coefficients a and b are expressed in terms of k. A is equal to 3k plus 1, while b is equal to 11 plus k, while c is just 9. What should be the value of k so that the roots are equal? Recall that if the roots are equal, which means that the roots are also real, the discriminant must be 0. So, it also means that b squared minus 4ac is equal to 0. By substitution, what equation can be written for the discriminant of the equation that must be set equal to 0? It is square of the quantity 11 plus k minus the product of 4, the binomial 3k plus 1, and 9 equals 0. But what is the square of 11 plus k equal to? What about the product of 4, 3k plus 1, and 9? If you're able to determine the correct answers, the equation will now look like this. 121 plus 22k plus k squared minus the quantity 108k plus 36 equals 0. Then, we combine similar terms and arrange the terms in descending powers. And this will result into what quadratic equation? Compare your answer with mine. K squared minus 86k plus 85 equals 0. So, we have to solve the quadratic equation to identify the value or values of k. What method do you prefer to use? I opt to solve it by factoring. Could you also solve it by factoring? So here are the factors. The binomial k minus 85 and k minus 1 set equal to 0. Then, by applying zero product property, what are the values of k? They are k sub 1 is 85 and k sub 2 is 1. Problem solved! Substituting the obtained values of k, the equation can be written as 256x squared plus 96x plus 9 equals 0 when k is equal to 85. Its roots are equal. X sub 1 and x sub 2 are both equivalent to negative 3 over 16. 4x squared plus 12x plus 9 equals 0 when k is equal to 1. Its roots are also equal. X sub 1 and x sub 2 are equal to negative 3 over 2. And that's it, Kagamath. I hope today's episode has been very helpful. This is your soulmate, Teacher Andrew. Before we go off air, let me share one of the mottos I hold on to as a mathematics teacher and learner at the same time. Math means mistakes allow thinking to happen. See you again next time as we face, overcome, and befriend the challenges ahead. We can because we are Mati-Mati Sinyan.